These are 3.4 student notes for Algebra 1 on solutions to linear functions. So a solution to a linear function is a coordinate pair, it's an x and a y, that when plugged into the equation will make it work or make it true. It also would be considered when you have an equation and you graph it. Let's say we have a line that's graphed. This is the x-axis, this is the y. It's any x and y where the point falls exactly on the line. Okay? So that if you were to have the equation of this line and you went to y equals, put it into y equals and went to your table, all of the points on this line are going to be the solutions to the equation. They're all the x's and y's that make the equation work. Okay, so we're given an equation here in this first question, and it says complete the table to find out some solutions. So in this case, what they're doing is giving us the x, which we're going to plug in for the x in here, and then solve and figure out what y is. Okay, so let's just do that real quick. If x is negative 2, now remember, here's our equation, is 2x plus 1. So I'm going to take 2 times negative 2, because I'm plugging the negative 2 in, plus 1. So that's negative 4 plus 1 is negative 3. So when x is negative 2, y is negative 3. So the next one, we're going to take 2, and we're going to multiply times negative 1.5, because x is negative 1.5. We're going to plug that in, plus 1. 2 times negative 1.5 is negative 3, plus 1 is negative 2. So we have negative 1.5, comma, negative 2. Now let's try 0. Same equation each time, 2x plus 1. So I'm plugging in 0 for x, I'm substituting it, plus 1. So 2 times 0 is 0, plus 1 is 1. So when x is 0, y is 1. And finally, we're going to do 2 times 1 plus 1. So that's 2 plus 1 is 3. So when x is 1, y is 3. Now, I do want to mention that we went through this process to figure it out. You could just as easily take this equation right here, put it into y equals in your calculator, hit second graph to go to your table, and look at all these x's, and then you could plug in these y's by finding them in the table. Can do that just as well. Okay, now it says, are these points that we have over here on the left, number 1, the only solutions to the equation y equals 2x plus 1? What do you think? I hope you're thinking no, because we can put any number we want in for x on this equation, and we can find the corresponding y. Because if we were to graph that line, again, if this is x and this is y, if I were to graph that line, 2x plus 1, which is going to go like that, it's going to go on to infinity. There's an infinite number of x's and y's that we can put in, x's that we can put in and get y. So there's infinite solutions. We can put anything in for x and figure out what y is on that equation. Now it says, is 6.5 comma 14 a solution? Well, the way we'd know that is to just try it and see. Let's try the x. So we're going to say 2 times 6.5 plus 1. And when you do that, you find out that 2 times 6.5 is 13 plus 1 equals 14. And is that what it says the y should be? 14? Yes. So yes, this is a solution. Okay? How about I try one that's not a solution, just for grins. Let's How about I try the numbers? I'm going to give you something that we can do. How about we try the number 4? I'm going to erase what I have here. What if I said is 4 comma 8 a solution? Well, let's try it. 2 times 4 plus 1. We're plugging that in, so I get 8 plus 1 equals 9. So when x is 4, y should be 9, not 8 like this, so that would not be a solution. So I hope you're understanding how that works. Okay, is negative 2 comma 1 a solution for this equation right here? Well, let's plug it in and see. We're going to do 3, and instead of x, we're going to put in x, because this is x, this is y. 3 times negative 2 plus y is 1, should be negative 5. So we have negative 6 plus 1 equals negative 5. Does negative 6 plus 1 equal negative 5? Yes, it does. So yes, that's a solution. It makes the equation true. It works out on both sides. Okay, let's try number 5. Which of these ordered pairs is not a solution to the equation 2x minus y equals 12? Well, we could take each one of these. We could do 2 times 3 minus negative 6, which means plus 6. That would be 6 plus 6 equals 12. Does that make this equation work? Yes, it does, because it's supposed to equal 12. So 12 equals 12. That one works. We can do 2 times 7 minus 2. Does that equal 12? Well, 2 times 7 is 14 minus 2 equals 12. 12 equals 12. Is that a solution? Yes. How about 2 times negative 4 minus negative 18? Well, minus negative 18 is going to be plus 18. So we have negative 8 plus 18 is supposed to equal 12. Well, negative 8 plus 18 is 10. Uh-oh. 10 does not equal 12, so that is not a solution. And let's try the last one. 2 times negative 8 minus negative 28 equals 12. So this is negative 16 plus 28, because minus a negative means plus, equals 12. And sure enough, we get 12 equals 12. So this one is a solution. So this one is the wrong one. It did not make the equation true. Now, the other thing you could do in that equation is go like this. If we have 2x minus y equals 12, let's solve it for y. Take the x over and then divide. So we get negative y equals negative 2x plus 12. And then to solve it for y at this point, we would divide by negative 1, and we get y equals 2x minus 12. There's the equation. You could put that into y equals in your calculator and go to the table and check for all these points. That's another way to do this problem. Okay, let's look at number 6. It says solve this equation, and it says given the domain, here's the domain. Now, so when it says given the domain, when we're given a domain, are we being given the x's or are we given the y's? The domain is always the x's. Domain is x. So it's saying if you take these x's and plug them into this equation, what's y going to be? Well, I think the easiest way to do this would be to solve this equation for y. Let's divide everything by 4. So I get y equals x minus 3. Now go pop that puppy into your calculator, go to your table, and let's find the answers for those. So when I look at my table, when I see x is negative 3, I see y is negative 6. And when x is 0, y is negative 3. Now, it's a little bit hard to find 1/2 on your calculator, and there's some ways that you can change it. If you hit your second button and then the window button, second window, and at the very top where it says table start, just clear that and put that you wanted to start at 1/2. And when you do that, now when you go to the table, it's starting at 1/2, and so we know that at 0.5 or 1/2, the answer is negative 2.5. So if the domain is this, negative 3, 0, and 1/2, here is the range, because the range is always the y's. So the range is negative 6, negative 3, negative 2.5. Now, it says for the same equation, what is the value of y if 5 comma y is a solution? Well, 5 comma y is just another way of saying x and y. So x is 5 and y we don't know. So just take your equation, y equals x minus 3, go back to your table, and let's figure out what it is when y equals 5. And when you do that, you find out, or not when y equals 5, when x equals 5. When x equals 5, what's y? Y is equal to 2. You can use the calculator, or you could just plug it in. 5 minus 3, what is? Y equals 2. Bam, you got it done. Okay, let's turn to the back. Okay, it says on number 7, solve the equation 5y equals 10x minus 5 given the range. So they gave us the range here. Well, when they give you the range, they're giving you the y's and telling you to find the x's. Okay, so there's two ways we could do this. First thing would be to take our equation and plug these in and solve. So 5y, we would start with 5 times negative 7, plug that in for y, equals 10x minus 5. So I get negative 35 equals 10x minus 5. Add 5 to both sides, and I get negative 30 equals 10x. Divide by 10, and x equals negative 3. So when y, remember on this one they gave us the y, negative 7, we know that x is negative 3. And then we could do that again for positive 7 and then again for 11. But the alternative way to solving that would be this. Let's take this equation, 5y equals 10x minus 5, and divide everything by 5. Let's solve it for y. We get y equals 2x minus 1. And then go to your calculator and type that in, 2x minus 1, and then look at your table. And we can double check our answer from the first one. Well, here's what you're going to have to do. Because they're giving you the y's, you're going to have to scroll up and down until you see these numbers on the y column. There's no way to plug it in on your calculator the way you can do x's. So we're just looking for negative 7. And I found negative 7, and guess what? X is negative 3, just like we said. Then, so I'm just looking, I'm scrolling up and down, I'm looking, and I find a 7. And where I find 7 on the y column, I see 4 on the x column. And then I find 11 on the y column, I find 6 on the x column. Okay, so that way is a little bit trickier because you can't just put in x and get y. You have to see if the y's are located there on your calculator. But at any rate, we were able to do it for this problem. Negative 3, 4, and 6 are the domain. Those are the x's that go with these y's. Okay, let's do number 8. In the equation 6.5x plus 1.4y equals 59, what is the value of x to satisfy this solution, x comma 5? So let's think about that. X comma 5 means we don't know the x, but we do know the y. We don't know the x, but we do know the y. So let's plug it in. 6.5x plus 1.4 times 5 equals 59. Okay, so let's use our calculator. This we're just going to bring down. Then we're going to take 1.4 times 5, and we get plus 7 equals, that should be 59 right there, 59. Now let's subtract 7 from both sides. 6.5x equals 52. So we're going to take 52 and we're going to divide both sides by 6.5. So we divide this by 6.5, those cancel out, divide by 6.5, and we find x equals 8. Bam! So remember, on these grids, it does not matter where you put the 8. It could be over here, it could be over here, it could be right in the middle. Doesn't really matter. The real issue is, did you bubble it in? Come down here to number 8 and make sure you've bubbled it in. And if it happens to be negative, make sure you bubble in the negative sign. It doesn't matter if you bubble in the plus sign. It'll take that either way, but the negative sign you would have to bubble in. But we don't need a negative for this one. It's only 8, and so now you're done. That's the lesson, and we'll see you in class. Bye.